This is lesson 16, and in this lesson we're going to take a look at the map reports that were generated in our first 4 VHDL examples. To get to the map report, after you implement your design, you click on Reports and then double click on this map, and it'll bring up a map report. Here's the map report for example 1 on gates 2. Notice that we have 6 4-input lookup tables that we've used out of 1920. If you go back and look at the table at the end of the last lesson, you'll see that we're actually using the Basis 2 board here rather than the Nexus 2, which has considerably more lookup tables. We use a total of 3 slices because you remember that there are 2 lookup tables in each slice. And we've also used 8 I.O. blocks. So we want to see if we can figure out why this is the case. Here is the architecture, you remember, that shows the 2 lookup tables in each slice. So we have 2 lookup tables per slice. Remember, the lookup tables have 4 inputs and 1 output. Well, here was example 1. We had 2 inputs A and B and 6 outputs Z0 to Z5. So we're going to need a lookup table for each of these outputs. So that's going to be the 6, and each has 2 inputs, which works. So that answers the question of why we needed 6 lookup tables. Now, in example 2, how many do you think we'll need? Remember, example 2 was the 4-input gates, so here we have 4 inputs and 6 outputs. How many lookup tables do you think we'll need for example 2? Well, if you answered 6, you'd be correct. The same number, because even though we had 4 inputs, each lookup table can handle up to 4 inputs. But we needed 6 to get the 6 outputs. Notice the total number of outputs is 10 now, because we have the 6 outputs plus the 4 inputs. How about example 3? Remember, we did the majority circuit? That had these 4 inputs, A, B, C, D, and the output F. This was the logic equation for the majority circuit. How many lookup tables do you think this one would need? Well, if you answered 1, you'd be correct. Just 1 lookup table, because remember, the lookup table has 4 inputs and 1 outputs, which is all we had in this circuit. Only needed 1 slice. We needed 5 outputs, the 4 inputs plus the 1 output. And finally, we did the 2-bit comparator. The 2-bit comparator in example 4, we had A and B, each with 2 inputs, so it's a total of 4 inputs, and the 3 outputs, A equal B, A greater than B, A less than B. How many lookup tables and I.O. blocks do you think? Here's the architecture. Yeah, we needed 3 lookup tables because we only had the 3 outputs, A equal B, A less than B, and A greater than B. And there were 4 inputs. Well, that's handled by each lookup table has 4 inputs. We had a total of 7 I.O. blocks, the 3 outputs and the 4 inputs. And of course we needed 2 slices because each slice only contains 2 of the lookup tables.